Hey everyone, welcome back to my YouTube channel. So today we are going to solve a numerical of the chapter design and constructions of the sewer. So we have asked the combined sewer sections for the area 85 hectares residential area and the runoff coefficient is given. So here solution given area is equal to 85 hectares. The average runoff coefficient is 0.5, so C is equal to 0.45 for solving altogether 1500 population. So the total population is equal to 1500. Now the average rainfall duration is 26 minutes, so T will be 26 minutes while calculating the intensity. So intensity of rainfall will be 1020 by T plus 20, which will be equal to 1020 by 26 plus 20, that is 22.17 mm per hour. Now the self-cleansing velocity is 0.98 meter per second. So self-cleansing velocity is 0.98 meter per second. We will calculate the velocity of the flow. If velocity of the flow will be greater than the self-cleansing velocity, then that will be okay. We will design for that velocity. The self-cleansing velocity will be maintained for that. So now the here slope, for the slope while using the Manning equation, here we have given the residential area have average elevation difference of 22 meter in horizontal, 5 kilometer longitudinal distance. So here for the slope here, while going 5 kilometer longitudinal distance, 5 kilometer will be 5 into 10 to the power 3 meter, horizontal will be 22 meter elevation difference, that will be in vertical. So for 1 meter horizontal we have 22 by 5 into 10 to the power 3, which will be equal to 22 by 5000 vertical. So for 1 meter horizontal distance we have 22 by 5000 vertical. So as will be slope will be 22 by 5000. Now we will calculate the total discharge of the sewer. So first we have to calculate quantity of the sanitary sewage and quantity of storm water. For the quantity of the sanitary sewage, we have 80% of the rate of the water supply. So 0.8 for the 1500 population in the residential area, we consider rate of water supply as 300 LPCD. So 80% of the rate of water supply, 300,000 into 24 into 3600 to convert it in cubic meter per second, times the total population, which is 1500, into the peak factor. So for we will peak factor is normally from 2 to 3. So for this we consider peak factor as 2. So 0.8 into 300 into 1500 into 2 by 1000 into 24 into 3600, which will be equal to is 8.85 into 10 to the power minus 3 cubic meter per second. Now the quantity of storm water will be equal to CIA by 360. So here the runoff coefficient is 0.45 into the intensity is 22.17 times the area is 85 hectares. divided by 360, which will be equal to 0.45 into 20.7 into 85 by 360, that is 2.35 cubic meter per second. Now the quantity of combined sewage will be equal to the quantity of sanitary sewage plus the quantity of storm water, which will be equal to 8.85 into 10 to power minus 3 plus 2.35, which is equal to plus 2.35, that 0.36 cubic meter per second. So here we have calculated the total discharge of the sewer. Now we have to check for the self cleansing velocity. For that we have Q is equal to 1 by n A r to power 2 by 3 and S to the power 1 by 2, or 2.36 is equal to 1 by 0.013, value of the ruggedity coefficient, and area. For area we have pi d square upon 4. This is d is the diameter of the sewer, and for the sewer running full or half we have r is equal to d by 4. So let us consider this running full, d by 4 times 2 by 3 into slope. Here we have calculated 22 by 500, 22 by 5000, 22 by 5000. Solving this we get the value of the diameter of the sewer, that is 2.36 is equal to 1 by 0.013 into x square by 4 times x by 4, 2 by 3 into 22 by 5000. So d is equal to 1.16 meter. Hence here the diameter of combined sewer is equal to 1.16 meter. To check whether the sewer maintain the self cleansing velocity or not, we have velocity is equal to 1 by n r to power 2 by 3 and s to power 1 by 2, which will be equal to 1 by 0.013 into 1.16 by 4 power 2 by 3 into 22 by 5000 to 1 by 2, which will be equal to 1 by 0.013 into 1.16 by 4 power 2 by 3 into 222 by 5000, that will be equal to 2.24 meter per second, which is greater than the given self cleansing velocity, that is 0.98 meter per second. 0.98 meter per second. Therefore here the self cleansing velocity will be maintained. Here self cleansing velocity will be maintained. Okay, so we will design the sewer for the given diameter 1.16 meter and the area of the sewer will be pi d square upon 4, which will be equal to pi into 1.16 square by 4, which is equal to pi into 1.16 times 1.16 square by 4, which is equal to 1.06 square meter. This will be the desired sections of a sewer for given 85 hectare residential area. This is all for today's video. Thank you so much for watching my video up to the last. Please subscribe my channel for more such videos. Thank you.